Welcome to Indefinite Integrals, Lesson 1, Antiderivatives. Okay, it's where we find what the original expression was before we took the derivative. So we're kind of going backwards. It's called integration. That's why it's called an integral. And the first integral that we have is the integral of 2x squared minus 2x to the negative 2. All right. Before we go any farther, let's just review what we already know. Okay? Let's say we had 2x cubed plus 5x to the 5th. Okay, what would we do? We would multiply the exponent down, make that 6, and subtract 1 from the exponent. To go backwards, we're going to add 1 to the exponent, 3, and then we're going to divide by or multiply by the reciprocal, so 1/3. So that's what we're going to do here. For these, we are going to add 1 to the exponent. That would be 3. And we're going to multiply by the reciprocal of 3, which is 1/3. So that would be 2/3, because there's a 2 out there already. Minus, wait a minute, we're going to add 1 to the exponent. So that would be x to the negative 1. And then we're going to multiply by the reciprocal. So that would be minus 2, but divided by negative 2, that would be plus 1. So 2/3 x cubed plus 1 over x plus c. Why do we say this plus c right here? Because we don't know what the actual constant was, or if there was a constant at all. We just know that the derivative was this, which means some constant could have disappeared. That constant could have been possibly 5, 7.2, square root of 2. Maybe even it was e to the 5th power, because that's just a constant. Whatever it was, it disappeared when we took the derivative. So here is the antiderivative. Let's go ahead and move on. Negative pi over x. All right, we can pull a constant out front. Negative pi 1 over x dx. And again, that's with respect to x. Okay, what is it that you get 1 over x when you take the derivative? Ooh, that was good. Okay, so negative pi, the ln of the absolute value of x, because we have to have the absolute value, because otherwise this won't work. It has to be a positive function. All right, there you go. Pretty fun, huh? Let's try another one, I dare you. Yeah. Okay. Ooh, this is not cool. Now, if we were to take the derivative of this, let's just think about this for a second. If we took the derivative of this, we would take the derivative of the exponent. That would be 2 times the original exponential. So it would be 10 e to the 3 minus 2x. Actually, it would be negative 10, because it would be the derivative is negative 2. All right, so the derivative of this exponent here is negative 2. So if we were taking the derivative, where'd that negative 2 go to? So we're going to divide by the derivative, e to the 3x, 3 minus 2x, plus some arbitrary constant. There's a little bit of algebraic shenanigans going on there, but when you take the derivative of this, you're going to multiply by a negative 2. Negative 5 halves times negative 2 would be a positive 5. That's a positive 5 right there. Some crazy stuff going on there, but let's go ahead and move along. Oh my. This thing, be careful. There's going to be a quiz question on this, and it's going to be, is it done by integration by parts? Is it done by integration by substitution? Is it done by both, or is it neither? It's a neither. Watch. I can simplify this and say the integral of 3x to the third minus 4x squared plus 5x minus 6 plus 7 over x. I just rewrote every fraction by itself. They were all over x, and then I reduced. Okay, add 1 to the exponent, 4, multiply by the reciprocal, that would be 1/4, 3/4. Minus. Okay, add 1 to the exponent, 3, x to the third, multiply by, wait a minute, I don't need to write 3 twice on that, do I? No, x to the third, multiply by 1/3, that would be 4/3. Add 1 to the exponent, squared, multiply by the reciprocal, 5/2. Okay, this one's pretty easy, minus 6x. And then we've got plus 7 ln of the absolute value of x. And of course, don't forget that arbitrary constant c. Let's go ahead and move right along. Okay, the integral of secant squared x plus 4 over 3x dx. Alright. Now we can separate that up too. Forgot to tell you that. When we're taking antiderivatives, we can also separate those up. Alright, let's see here. Anybody remember what secant squared x is the derivative of? Come on, work with me. Yes, that is good. Excellent. Good job, Jacob. No, not tam. That would be the tangent of, wow, I can't write. The tangent of x. Okay, plus, you can move that constant out front 4/3, and then this will just be 1 over x, and everybody knows that that 1 over x, the antiderivative by now, is the absolute value of the ln of the absolute value of x. And don't forget your arbitrary constant. And yes, I know if I do two different ones, I'm going to have two different constants. But if you add them together, you're going to get a third constant. Pretty crazy, huh? All right, let's move on. Please. Had enough yet? All right. Cosine is the derivative of what? It's the derivative of sine. So sine of 4x. But wait, there's no 4 out here. So if you divide this by 4, when you take the derivative, the chain rule, say multiply by a 4, and it'll multiply with that 4 there, and it will cancel out. It will work. Okay, the sine of negative 2x. All right, let's see here. That would be cosine. Sine is the antiderivative of negative cosine. So negative cosine of negative 2x all over negative 2, or you could just say the cosine of negative 2x over 2 plus some arbitrary constant which we don't really know what it is. And yes, I know, Noah, you can't see what I just wrote, so let me move it up so you can see it. Alright, and I'll move it up just a little bit farther to make sure that you can see everything I wrote. Alright, there you go. Thanks for reminding me again. Alright, let's move on, please. Alright, the integral of e to the 1/2 x minus 6. Alright, let's see here. What's the derivative? 1/2. So we're going to divide by 1/2. That'll be 2 e to the x over 2 minus 6 plus some arbitrary constant. Excellent, excellent. Alright, see? Now if you went to go take the derivative of this, okay, what would you do? You would take the derivative of the exponent 1/2, multiply that out front, and then multiply by the exponential, and that's what you would get. Yes, I know, it takes a little bit of work. Oh, hey, this one, fun times, let me tell you. Let's go ahead and move that constant out front. 4 times the integral of 1 over, hey, can we factor out a 5 here for me, please? Yes, x squared plus 1 dx. Let's go ahead and move this constant out front as well. Oh my gosh. Sorry, I didn't mean to say that. But yes, I'm over in this corner again. 4/5 times the integral of 1 over x squared plus 1 dx. Where have I seen this before? What is that the derivative of? Oh, you're going to have to look. Go find your basic derivative sheet, that whole sheet of derivatives. And then in there you'll find, because you haven't memorized this yet, and I told you to, 4/5 the tangent inverse of x plus some arbitrary constant c. And there you go. That was a lot of fun. No, actually, I enjoyed it. I'm not sure you didn't. Let's move on. I think I have a couple more examples. Oh, guess what? I don't have any more examples. Woohoo! This does end antiderivatives. That would be lesson 1 on indefinite integrals. Thank you, and enjoy.